Right, good morning. It's a very cloudy day today. So let's try. I've got some of this. I think they are quite little nice cells. If I unpack this one, it came with a very nice pack. Also with bars. So if I unpack them, and we got those very nice looking little cells. I can put the buying description. I can put the AliExpress link down the description, and maybe you can check them out. They have storage in, I think, in US and also in Germany, in Europe. So it's arrived pretty fast, even though the price is higher than probably than buying them directly from China. But I think they are a quite good seller. And I've got some of the small cells, and I want to make a small battery on the desktop, so I can connect with a USB connection. I can wire up a BMS and maybe write some simple software or program that can read the BMS status, so I don't have to always go to my corner of my living room and crouch on the ground to do the development. But also this small cell I think is pretty nice and pretty fun, because I could basically put them in a small 8 of them to have a 24 small battery pack system in a small tray like this, and maybe it can be used later on the bike, or if you go out camping with a car. This could be a nice small battery for your laptops, cameras, and cell phones. So each one of this is 20 an hour. Yes, so 8 of them will give you something like close to 480 watt hour small battery. That's pretty nice, and you can even stack more of them to have a higher voltage for the application, like electric bike or electric scooters. Nevertheless, let's try maybe build them today, see how far we can go. Okay, just to see what a minimum of equipment that we might be needed for doing the batteries, and of course some cabling, and also the some XT60 connectors for connecting wires conveniently, and some tools for the cable, and then of course the battery. And in this case I have them 8 of them put in here, and maybe a case for securing them later, and of course the battery connection bars. And then also I've got this thing. I think it will be very handy for some nice battery connectors. So this can be used for connecting a lot of cables together, but we could put basically battery positive here, and then have the BMS also connect onto it, and this will make us connecting multiple BMS at the same time for development purpose, and also can wire up a voltage, those active balancer on it. I think this could be nice. Let's try them out. And then maybe you also need some maybe a welder, solder, maybe that's what they call it, and also a hot glue might be handy to fix something later on. I also have some paper here. I want to put them in between the batteries, so make them secure. And maybe some tapes, which is not on the table here. Oh, forgot to mention, one of this is definitely needed. We're gonna have go measure the battery cells. See, the last one. I guess when we connect them, maybe put them out, then we can basically put a tape around it. That might be a better way to do it. Yeah, let's take them out. some of them is slightly, what you call it, swallowed or kind of pumped up a little bit. I'm not sure what causes that, but some of them was pretty flat. But let's see whether this is an issue when we start using these batteries. Hopefully not. Okay, the first thing is just to remove the thing on the top. Oh, one important thing when we are doing this type of stuff, and always remember to wear a protection glasses. I don't have a proper protection glasses, but I just use this one. You should probably use a better one. Of course, a BMS, I forgot to mention, you need this. And this is a QUCC BMS. Now we have the top cover removed, so those connections are exposed. Now we can connect those little connection tip or connection sticks onto them. Should be out. Nice and easy. Now let's try measure all the cell voltages, see if they are nicely aligned or not. Alright, starting from the first one on the left. Minus 3.21314, 32.0, so it's around, I don't know, 50 millivolt, 10 millivolt difference or something. 3.205, 3.209, 3.206, 3.209, 3.213, 3.213. Well, they are not perfectly balanced, but I think they are quite very close to each other, because the difference is just between the 3.2, let's say 13 millivolt to 09 millivolts, something like that. So that's like 5 millivolts difference or something. And I think that's perfectly okay, because we also have those cell balancers onto them. For example, this one, I got this I bought the QUCC BMS at the same time, so I think this would this is a smaller one. I think this could help. There's two different versions. I think one, let me just open this for you. I think there's two different versions of those cell balancers, and one of them is with those induction on them, and the other one is with large capacitors onto them. But let's try this one. I know the other one works pretty well, so I'll just rely on this one and not do a top balancing and charge them, because I think that's that could do as well, but it takes a little bit more time. This probably would just do. Alright, I think the next step is before we connecting the head onto the batteries, we're gonna make some connection bars. So basically those things on top of those things, which we wire those two together. That'll be the next step. But before moving that further, we want to realign the battery and put some paper in between and tape them around so they can be secured. Let's do that. Because I don't want them to attach to each other firmly, because I think that might be not good for if there's a certain vibration going on later in between the batteries. Just a little bit of damping in between. Okay. So next step is just to wrap this cell around a few circles with a tape like this at the bottom. Alright, so our cell is well attached. Now let's move on to some cables. This would be very simple as well, I suppose. Now we need 8 of those. And then we will attach some of those cables here. And the plan is to attach this one on the positive side. Then we can glue this one on the other negative side. So just put a little bit on the other side so it doesn't cover this indicator here. Yeah, like this. So we're gonna make a bunch of 8 cables with this length. First one. All right. And then we try to connect all these cables on the small blue ones. Perfect. Okay, now we have 8 those connections connected, made. Then we just remove the end part and then connect those two together. That should be fairly simple and straightforward. Let's put them in the middle. Very nice. I love those connectors. Well, I think I did a little bit wrong calculation here. Since we have 8 battery cells, we will actually need 9 of this because you would also need to wire the total battery B negative onto the BMS. So we need 1 more of this. And let's put some stickers on. For example, this is battery B minus. So let's write B minus. This would help. Now let's wire some cable for the main positive. I have this chip. I don't trust this thing so much, but I don't have another. I think this is the last, this physical fuse over here. We will just connect this one onto the battery as well. But later on, if I have a better fuse, I would basically switch this one out because they might not be reliable and they might not break when it reaches to 20 amps. I think I discovered this case while I was using a 100 amp circuit breaker with this cheap stuff. But let's for now just wiring this one, and use that one as a for slighter more safety. So now we have it. Basically, this would connect to the battery positive, and this is our battery kind of output connector, and this would wire up to the battery P minus on the BMS. I think we are almost there. Let's put these things on, put those on the battery, and then we can work on the BMS. BMS cables. It's a USB connection. All the voltage measuring cables. Finally, we have the battery management system. I have another video talks a little bit more details to this one, so we're not gonna mention too much about it. In my opinion, it's one of the best brand out there, and also the price is very decent. Now we just need to wire this B minus to a connector, to one of this connector, so we can wire this onto the battery, and the P minus part would be connected with this together to the output. This one support 80, it's a 6S to 16S, it supports 80 amps, but for my small battery application, I think it did only output 10 amps or 20 amps, perhaps mostly. So a cable like this is definitely good enough. And we have a 20 amp, if it works nicely, with a 20 amp circuit breaker here. Alright, let's get into it. I think the first part is just to remove the cable connection cable, the cable detectors. So this one here, battery minus. It kind of squishes in. All right, it's all secured. And then the few last step is to trim those cables and insulate a few ones that we don't use. Show you here. Firstly, we will combine there's two key cables over here that is used to turn on the BMS. And we leave them out here, and we have a two CAN cable, which marked as CAN L, CAN H. We're not gonna use that one, so we don't touch onto them. Then we can insulate them first. So it's those two cables. those two is the RS 485A and 485B cable, and they will be connected onto the, which is this guy. So we have A and B connection over here. Let's wire this up. Okay, I think I finally have made all the battery connectors, connections, cables, all trimmed well. And now let's see, finally assemble the whole batteries together. Let's firstly remove all the waste material here. Alright, let's put this in. Button. Yes, let's see. Do we have space for the BMS? It's kind of possible to put the BMS in there, but it will be a little bit squeezed. We'll have to see. So this one is all here. Yeah, let's do some connections. Eyeglasses. So the first thing is to wire up all this batteries. So we want to have the battery main negative over here maybe, and then we will have the battery total negative on this side. Right, then yeah, then we have the B minus basically cable over here. That should work. Sadly, because of the bars come with the battery, the last one, some of the pieces was slightly longer, and I don't want my battery pack to be extended. I want it to be very, very compact. So I had to basically put the two of them together, and this would solve my problem. Let's put them up in here. And finally, we can measure the total voltage right now. So we should have 25. Perfect. And this means that this connection is all corrected, and we just need to wire those things on the top. But before I do that, I might want to put the battery minus on the top, plus the B minus connection bar on the top, and here we will have the first one. This is the first one that should connect onto it. Now we have all put them together. Let's tighten the screws. Good, now everything's connected. And the next thing would be relatively simple, is to basically connect the BMS wirings, like this one here. Since we already made all the connectors, it will be super easy. Firstly, let's take those two temperature sensor out. Then we're starting from the B minus one. So this is B minus, the only black one. It should be correct. There we go. First cable, B minus, and it's very nice they actually marked out the cable, so it'll be very, very easy. B plus 1. So it's coming out. Plus 1 here. Okay. Plus 1. So those two are gonna connect together to the B plus 8. All good. Now the connection is all down, and let's put the temperature sensor in. One of them here maybe. Another one here. If I could squeeze them in. For the battery, similarly, we will also connect the battery active balancer cable the same way. Okay, now we have connect the battery voltage table also with the battery active balancer table, and now we just need to make sure they are correctly connected. Let's do a quick sanity check. So here we will have the black one pointing to the lowest one, and the voltage should just go one above, one more each level. Yeah, to 3.2. We have 6, 9.6, 12, 16, 19, 22, 25. So this is correct. And we also measure the battery one, and this is so here this is the negative one. This should be the first one. 3, 6, 9, 12, 16, 19, 22, 25. That's it. And also last one is also 25. Perfect. So this means our connection is all correct. Let's just do a little bit of cable management. I would really like to put the BMS later in here, but we will have to see whether we have enough space. So first thing first, let's connect the cable to the BMS. It's a very tight one. Good. And also with the key cable that will connect onto the BMS as well. And here we will use this connector to connect the final two key cables over here, as they are both marked with keys. That's important. So we connect the first one in there first. Yeah, leave it over there. Let's connect the BMS key cable. I could put the BMS a bit over into this guy. If possible, then it would be very perfect. Now we can squeeze the BMS in. Okay. All right, now we're back. So earlier I did a little bit of cable management, as you can see here. And then the only output we have right now is just those cables. We might wire a balancer later if we need to. I'm gonna stop them here for now. And then on the other hand is the cable, this 20 amp circuit breaker. I think we could basically put it over here, and then this would become the battery output. Let's use a sticker here to temporarily put this guy on the side. There we go. And this cable can perhaps also be put inside if I could find a good place for it. Okay, so this is the BMS over here, and in order to turn the BMS on, the last step is to connecting those two key cables, and then we will have to set the BMS to 8 battery cell instead of, I think by default they have 16. So let's connect it right now, see what happens. Oh, I can see the Bluetooth is lights up. Also the BMS is lights up. Don't know if you can see the lights at the corner. And then we need to see that with this app. See if you could find this the new BMS. Maybe it's at the bottom. Yes, I think it's this one, and you can see the measurement is actually wrong. And we just need to basically, I remember last time, in order to change it, I show you in English, in the configuration, we have to change the total number of cells from 60 to 8. This is important. And also I think, let me see, in the English, their English menu is not so good, but on the Chinese ones I have the full name, so I can make sure that this is the design capacity. We set it to 20. Also here set to 20, and I think if you don't care about the rest, and this would be the simple setup, and we can do the fine-tuning later on. And apparently this connection, the voltage is not correct, and right now what I need to do is to basically restart it. Okay, let's see if that works. Now I just disconnect this cable and then connect it again. I think all their for this version the BMS start with JDY or something. See, now most of the power the parameter is correctly calculated. So we have M is 0, we have 25.7 volts in total, and the min and max is also each cell voltage. We can actually read it from here, and also the temperature sensor. So this is ready, and the state of charge is not correct, and all we need to do is later to charge it, the battery, to a certain voltage. There is a setting, and when it's reached that one, it will be showing 100%, and from there it will do the counting of the current when you discharge it and calculate the state of charge correctly. So final just tune is here is the voltage full, and also the voltage sorry, so here we have the voltage full. Yeah, I think I can go set it to around 34 millivolts because I don't want to charge it charge the battery too high. 34, maybe 35. So that's actually the cell voltage. And when it's empty, I set it to not that low, so shrink down this whole thing a little bit. Okay, I think this is all good, and let's see if we could get the voltage reading on the final XT60 readers. And we need to also connect this. Now it's connected. So we have negative. I don't know if you can see it here. No, there's no voltage. Let me double check what's going on. So sadly, this is not working. Maybe I should just remove it for now and use another one later on. Use a good fuse later on. So now I have made a simple solution by connecting some wire connectors and then also a 20 amp fuse over here. And this should make it secure. And let's try double verify the power output. The voltage output, sorry. Now we have 20 volts, 25 volts. So this is all working. And now we just need to put the things back. And this is as far as I can do. And maybe the next step could be just drill some holes on the top or on the bottom to actually let the cable actually go through those places, so we don't have a totally ugly looking connected cable connections over here. But it connects. Now we have our battery. Good. Oh, let's put this one on top for now. It's not really good looking, but also a little bit crazy. but at least we have a battery. And I think it will work nicely. This would be the connecting part. And yeah, maybe let's put this up. See whether it works. No smoke, hopefully. B minus, B plus. This cable is also correct. Oh, I can hear the current. Things moving. Let's double check the current voltage. So we have 3.211 and 3.201. So like I said, like 7 millivolt difference. And yeah, let's put this one working and see how long does it take to maybe make the cell voltage difference more constant or not. Let's see whether this can reduce the cell voltage difference. So I think we could basically put this one over here for now. And let's see whether this one burns up or not. This is off. This is on. Perfect. Let me go throw away. So now we have the battery. How do you like it? With the BMS hardly squeezed in here. And on the other side, this is the Bluetooth module. However, this cover is just slightly not optimal looking, but I'm pretty sure we could do something about it later. Yeah, let's maybe connecting our computer onto it and then put also a small load onto it, see what happens. Be right back. Okay, now let's try connect the USB to our computer and see whether the simple application I was developing to see that whether it can connect it to the software. I don't know if you can see the screen, but let's try run it. Haha, it started. And you can see here the current is 0 amp. It's super small. I don't know if you could see it. Move this a little bit closer. Yeah, you can see the voltage reading and also the amp reading here. There we go. Yeah, now you can see the voltage. Now you can see the voltage reading and current reading, and cell count, and also those cell voltages we were measured that with 1 to 8. So this is nice. Let's try to power the this laptop with the battery and see if we get a good current reading or not. And before I do that, I think there's a special parameters we need to change to make sure that we can measure the current precisely. I'll switch to Chinese right now since it's easier for me to do that. And then that measurement thing is called, I think it is bias current. Let's put it into 0.2 amps. See if that works. Okay, in order to power the batteries, we can power my computer. We can use one of this very nice DC to USB. So it's like this. Now we just need to find it support 12 to 28 volt input. Now we just need to find an adapter to connect the power to this guy. Be right back. I've got this connecting cable. Connect onto this one. This thing should light up. Smart, right? And all I need is just a USB-C cable. Just need a USB-C input. Let's go over here. We can actually read the output voltage and also the output current. That's very nice. Let's just leave this one over here. Now we are connecting to the battery. Let's see if this current reading has any good changes. Not charging. See? Now we are drawing 2 or 3 amps. Also from here we can see it has 20 volts, 0.42 amps. So that's we have the same reading here towards this reading. So it's already here. Yeah, so this laptop is very energy saving, and it's super nice. Now I have a fully nice working battery pack, and I'm pretty happy with that. And I also hope you also enjoyed watching this video, to spend the whole morning together with me to put up this battery. And thank you for watching. See you next time.